Welcome. This is Geometry B, Unit 5, Circles, Lesson 4, Circles and Triangles. We're going to construct, so get your compass and straight edge out, and we're going to construct two things. We're going to construct something called the incircle, or the inscribed circle, and we're going to construct something called the circumcircle, or the circumscribed circle. The incircle is a circle that just barely fits inside a triangle. The circumscribed circle, or the circumcircle, is a circle that just touches all three corners of the triangle. We're going to start with the incircle. Okay. To construct the incircle, or inscribed circle, we're going to construct something called the angle bisectors. This is a construction we did last semester. Angle bisector. So, let me remind you of the steps. I'll do them separately. I can combine them and save some steps, but I don't want to confuse the issue here. So we're going to make an arc that crosses both legs. We're going to put the compass on one intersection. I can change the size right here if I want to. Draw an arc in the interior of the angle and keep the same arc, so we're going to copy that arc to an intersection point, and we're going to draw the angle bisector. So the angle bisector connects the vertex to the intersection that we just drew. So that's the angle bisector. Let's go ahead and find the angle bisector of the other two sides. Other two angles. Okay, so we're going to put our compass point on one intersection. I'm going to shrink it down a little bit. I'm going to put my compass on another intersection here, and I'm going to shrink it down a little more and draw an interior. Copy that same arc to the other intersection point, and then draw a line through the vertex and the intersection of the two arcs. It's always interesting to see how close we actually get. These three angle bisectors should meet at one point. The word for that is concurrent. They should be concurrent. They should intersect at the same point. So again, I'm going to shrink this down here a little bit. Draw an arc out here. I'm going to make this a little larger here. And copy that arc to the other intersection. And draw a line or a ray from the vertex through the intersection point. And we came out really pretty good. There we go. All right, and they all meet at one location. One location. And that point is called the incenter. Incenter. The incenter is the center of the inscribed circle, or the incircle, and it is the point of concurrence of the angle bisectors. Concurrence, C-O-N-C-U-R-R-E-N-C. Concurrence means to be simultaneous, one on top of the other. Okay? All right. So now we need one more step. We've got the center of the circumcircle. I'm going to change colors here. We've got the incenter. Now we need to get one point on the circle. So we need a point that is closest on one of the sides. It doesn't matter which side. So now I'm going to construct the perpendicular line from this point through. I'm going to go with the hypotenuse, through the hypotenuse here. So we're going to draw an arc from there that crosses more than once, and we're going to put it on one intersection. It's almost like the angle bisector construction. Okay, there we go. And we're going to draw a line through the center, the in-center, and through this intersection point. Okay, and there we go. Okay, that's a perpendicular. Lots of intersecting parts here. And there's the point on the circle. So now that's a radius. And so I can now draw the radius, line up the center, line up that point, and hopefully, if you've done it correctly, if you've done it precisely, this circle will just touch all three sides. And that's the in circle, or the inscribed circle, whose center is the in-center, and is found by the point of concurrence of the angle bisectors. Boy, there's a lot of vocabulary here, isn't there? All right, now that's construction number 1. Feel free to review this. You will be expected to know how to do this construction, and do this construction on the test, if not a portfolio. All right, so now let's hide this layer, and let's go do the circumcircle. That is a circle that goes around the outside of the triangle and just touches the corners. Okay, this is called the circumcircle. Circum means circumcircle. Circum means around. Like Magellan and his crew. Magellan died on the way, but Magellan's crew circumnavigated the globe. They went all the way around the globe. Circle around is literally what circumcircle means. Also circumscribed circle. It's the point of concurrence of the perpendicular bisectors of the sides. Perpendicular bisectors. And again, it's the point of concurrence. It's where they cross. Okay? And the center of the circumcircle is the circumcenter. Okay? All right, so let's construct the perpendicular bisectors of each side. Now in this case, I'm going to use some economy. I'm going to use the same arcs, otherwise we get a lot of arcs overlapping. So I'm going to start with the longest side, expand my compass so that it's more than halfway, swing an arc that crosses all the way through the triangle. Okay? And keep it the same size and go over to the other side and do the same. Swing it all the way through the circle and almost all the way around. And then continue over here. Right there. So we do it from all three corners. And you'll see if you look at it, they're overlapping a bit, but 3 footballs. Okay? We're going to connect the tips of the footballs. That's a technical construction term, footballs. Okay. There we go. So there's the perpendicular bisector of the shortest side. Let's go to this little football here. And we want to connect the tips of the football. Okay. There's the perpendicular bisector of the long side. And the perpendicular bisector of the medium side. Connect the tips of the football here. And again, you'll notice they're all concurrent. They all meet at one place. Okay? Right here. And this point is called the circumcenter. Okay? Luckily, I don't have to find the points that the circle is going to go through. The circle is going to go through all the corners, all the vertices. Okay? And so here we go. Let's put our compass on the center and line up the circle with one of the corners, and hopefully it's going to line up with all of them. I usually find I've got to do a little bit of fudging here, but the idea is that it should, if you did a perfect construction, it should perfectly line up and go through every corner of the triangle. And that's a circumscribed circle or a circumcircle. It's formed by the perpendicular bisectors to find the point of intersection called the circumcenter. All right, now for a little brief explanation as to why this works. You recall the perpendicular bisector theorem. It says that any point on the perpendicular bisector is equidistant from the endpoints. So any point on this line is equidistant from the endpoints. Okay? Well, also, any point on this line is equidistant from the endpoints. And any point on this line is equidistant from the endpoint. So what we have found is we found the one point that is equidistant from all of the corners of the triangle. All of these are the same distance. And what is a circle? A circle is a shape created in a plane where all points are equidistant from the center of the circle. Okay? The same sort of argument works for the in-center. So let's go there. You may recall the rule that says for an angle bisector, every point on the angle bisector is equidistant from the sides. So all the points on this red line are equidistant from these two sides. All the points on this angle bisector are equidistant from the sides. And all the points on this angle bisector are equidistant from the sides. Therefore, where they intersect is the one point that is equidistant from all three sides simultaneously. And so we can draw a circle because a circle is a shape in which all points are equidistant from one. Okay? So that's kind of the reasoning and the argument as to why it works. All right? Hopefully that helps. Happy constructing.